how to do speaker notes and
yes, you use another screen and you share the offsite screen and then in the front screen.
That's a good point. Okay, cool. So yeah, I think in terms of a very quick introduction, I'm very passionate about this subject. Basically, why I'm passionate is because I've seen this leading to growth. A lot of, most tech companies, be it online ads or YouTube and Netflix, etc., they had a product, and then a lot of their growth came from recommender systems. Today, a lot of the work inside both like on ML infrastructure and sort of new modeling techniques, everything is around growth, and recommender systems are a key part. But apart from that, objectives of the meeting are to get us to add recommender systems more in our thinking process, in what we feel we can build sooner than later. Key results are, we'll try to cover 3 aspects, and later I'll send a sort of a feedback form to see how much we covered all 3 aspects. There'll be a quiz. Last 5 minutes, we'll go over a quiz together. We will all do a quiz together. And then sort of the 3rd key result is asking for volunteers of sort of a working group. There are all these aspects. Okay. Any questions before I move on? Okay. By the way, I've sort of set it up as a group discussion, not that much as a talk. It is not like one of the non-goals, for instance, it's not ML heavy. It's not a tutorial, but I have listed these resources for us to do together. Yeah. Okay, to start with, this slide is premature from the sense that I'll talk about terms that I have not introduced, but I think it's important to start with why we are here, and it's because of work from people like them. John Riedel, Professor Riedel Emeritus, is, I believe he passed it. But anyways, he did a lot of seminal work in collaborative filtering, user modeling, I think late 90s, early 2000s. All the terms we talk about today sort of came from him and collaborators. Yoda Koren, the middle 3 people are people I worked with in Google. Yoda Koren, he is famous from the Netflix Prize 2007 or 8, I think, where they used matrix factorization for collaborative, for figuring out movie recommendations. And then that sort of led to a lot of work, which now is called 2-tower models, embedding-based models. Stefan Rendell, he figured out that, hey, it would be nice to use all the other contexts that we have, but like earlier, till Yehuda's work, we would use only the fact that which user listened to which song, if it's music recommendation, just those links between users and items. Just that's all we'd use to recommend for future. But Stefan's method uses the features of the user, features of the item also. Like, for instance, this the language of the item. When was it released? What are the words in the description? Stuff like that. Jim, yeah, you won't find anything about him. No papers, but he. Distinguished engineer at Google, now at Waymo, he made it happen. He went to YouTube and said, I want to try to use an ML approach to make the homepage. And at the time, people had sort of a page rank sort of method, a more non-ML approach, and he sort of made it happen over time. And now 67 billion hours of videos I've watched every day based on his stuff. Joe Leskovich, chief scientist at Pinterest. Huge contributions in graph neural networks based recommendation. Okay, so getting some terminology right, and in the interest of speeding things up, whoever wants to answer, please answer. What's your recommendation? Just what do you think is a recommendation? I'll tell you about the slide later, but just what's your answer? What's your recommendation? Anyone?
Well, recommendation is when the system suggests something else for you to listen or see based on what you've done before.
Yeah, yeah. A technical term we use is topic-less recommendation. You have not explicitly stated an intent. System is just looking at your history and other stuff and recommending. What is search on the contrary is called topic-full recommendation. So you've explicitly stated a context, an intent, what you're looking for. And personalized recommendation is different from recommendation because, yeah, you could recommend based on, okay, this is Black Friday, so I'm going to recommend electronics, or recommend based on your history, and that would be personalized. The thing I'm trying to show here, the left is the app before we started working on it, is a Google Podcast app, and there are recommendations in there. It's a little Conan O'Brien thing at the bottom. Everything else you see is not personalized. In fact, the app used to open at the home tab at the bottom, which just had content from your subscriptions. So if you're a new user, you didn't have subscriptions, that tab would be empty. I'm trying to show a user experience which does not bet on recommendation. On the right is, the user listened to this TikTok and beyond podcast. This is me, of course, and I listened to that, and then my sort of recommendations changed. You see Master of Scale and Microsoft and Discord, presumably because they are similar to what I listened. Okay. So just to ground it, we have the user coming to your app, saying, tapping on it, and you need to show a list of items. This calls the recommendation service with just the user ID. And the recommendation service is supposed to return a list of items. And everything here, what we refer to as personalized recommendation, everything the service has to do. So for instance, it has to access user item interactions. It has to see what are the items to be served. I have not made a box for it. What is the inventory? It has to, once it gets the items to be served, it has to find the metadata for it. For instance, if you want to show like a LinkedIn feed, you'll probably have one service which gets you the feed IDs. These are the items to show to the user, and then you'll need another service to get the actual documents for those feeds. So this is this guy. And again, this is high level, but any questions on what we mean by the recommendation service? Okay.
So why is the modeling platform off to the right and the recommendation service off to the left here? Wouldn't you think that they will be touching each other now?
Yeah. So they are talking to each other through this, boundary here. So periodically you're computing sort of, let's say, the embeddings or the models that you want to be used in serving and injecting them as a dependency. And this is your serving flow. This is what actually happens when a user comes. So this is kind of offline, and this is online. A good question Bhavna and I were talking the other day is, this is sort of a big tech flow, and for us, for cost optimization, we might want to compute the recommendations also sort of not offline, based on an event, sort of the event processing, not too much of it online to reduce costs. Okay.
Got a quick question on that.
Yeah.
I'm always puzzled with the latency, like how fast the recommendation engine response.
Yeah.
Right. Where do you think is this coming from? Like what
Yeah.
what piece of the architecture is driving that?
I'll answer this question when I get to this slide. I'm going to actually answer exactly per line how much is the latency. Okay. But thanks. Please remind me if I somehow forget at the time. Okay. So yeah, I mentioned a lot of people in companies like Google work on recommendations, but why? So yeah, I mean, I know we can imagine that, but let's go over this again. For an app, you need acquisition. That means you need people to try out the app, and then you need to get them to understand what this app is. Recommendation is the biggest growth lever. For instance, let's say a user is new to the platform, and sort of a recommendation can sort of very intuitively explain the product to the user without you having to sort of educate, okay, do this, do that, and this is your aha moment or something like that. They'll feel it by the strength of your recommendations. You should feel sort of an epiphany what this product is about. Like one example that example know very well in Facebook, you come here and people you may know is the first thing you see. People you may know shows you, Facebook is about my friends, Facebook didn't say that, it's trying to make you feel that by people you may know. Retention. Again, YouTube is a good example of retention. It's constantly showing you things that make you want to come back. And in fact, they goal on retention. They goal on like, how can I change my recommendation service so that users come every day? Not that they watch a lot today and don't come back, but they, they come more often. The line at the top is personalization was very useful to us in podcasts. Please keep this confidential. But first when we built podcast recommendations, initially it was unpersonalized. We did the best job we could based on unpersonalized data. And we got to a click-through rate, CTR, click-through rate of 0.91%, which means that roughly out of 100 recommendations, user would listen to one. It's not bad, by the way. Yeah, Facebook ads has a click-through rate of 1.4%. I'm not sure Google ads, but I'm just trying to say 0.91% is not horrible. And after personalization and a lot of personalization, we got to 8.1%.
But Gaurav, cost per impression. So are the ad technologies somehow incentivized to just show an impression and make money, or are they incentivized to not just show an impression but also have a click on it?
No, the monetary value of a click is about like 500 times more than an impression. Both they make money, but just much more money from a click.
Gaurav, quick question. Was this based entirely on behavioral data or also demographic and psychographic?
I think what you're saying is, how did you personalize? Did you just personalize based on what I've listened to in the past, or that I'm a male living in this area? And yeah, I mean, different companies have different rules. I think Facebook will use everything under the sun, but Google, certainly you cannot use gender. But there are other things also you can't use, like you can't use the fact that the person watches right-wing content or things like that. That's more a policy decision.
So does the model itself improves every time it does quote unquote the right thing? Like, how does the feedback go back into the original model of whether somebody is actually using those recommendations or not?
Yeah, no, I mean, that's the right question. So very simply, what you need to do is this thing. You need to log the feedback. You need to build a modeling platform that use TensorFlow, etc., but that you can train a model based on this, and you need to inject it during serving time. So starts with logging a privacy preserving. I mean something that your data is not accessible to me. As you're a user, I'm a user, I should not be able to touch your data. So some sort of storage that preserves that, and then make it sort of a MapReduce framework so that you can train your models using the log data, and then serve.
And Gaurav, sorry, go ahead, Nim.
Sorry, no, I'll follow.
Intent of the advertiser versus the recommendation of the platform.
Yeah.
Like this advertiser definitely has a lot of intent as well. Yeah. They're like, I want to only show ads to folks who are graduating from top 10 graduate CS schools.
Yeah.
Versus whatever. So what percentage of what, let's say Google, Facebook do is based on intent versus intentless?
Yeah, so I think there are two ways to answer that question. One is the universal ad format, and the other is the way you described it, that this age group haven't graduated something. So this SQL sort of format is the old school Google ads. You know, there's so many fields, I think Facebook also, so many fields you can. So most of them use that, but they are all moving towards this universal ad format, where the target audience is sort of embedding based. They are being learned based on what is the message that the advertiser wants to put forward, and which audience is resonating with that message. I'm interpreting your question as that what percentage of advertisers specify these filters versus what percentage use this semantic method.
Yeah, it's like what percentage of advertising is still rule-based? And my guess is that there's a lot that goes on which is still rule-based.
Even in the rule-based, let's say I'm Booking.com, which I believe is the biggest advertiser for Google. They will have rules, but let's say they have bid on a keyword, Hawaii, for instance. After that, whether when I search Hawaii, whether that ad is shown or some other ad is shown, there you have a what is called a PCTR model, probabilistic click-through rate model, means a recommendation model, which predicts the probability of my clicking on that ad. Yeah, Nim, you were saying?
Yeah, I just want to follow up on Madhukar's question on learning from previous recommendations. So I'm guessing when you say here store interactions and user item interaction, this is a lot more richer than just user item interaction, because it's really user item recommendation interaction, right?
No, yeah, good point. Good point. You know, when we started podcast, we just had user item interaction data. There was no recommendations feed. We just had positive examples, so to speak, that this user listened to this item. Later on, took us a year and 2 months to build it. Later on, we also logged that a user came, we recommended these 20 items in this order, and then they click the 5th item. But it takes time to build that. Okay.
Does that influence the ranking then, what you actually show as an important news versus less important news?
Right, so the second logs that we generated, this is more directly usable in training your model. This actually knows also. Imagine I show you 10 items and you click on the 5th one. That means 1 to 4 are not as good as the 5th one. So this is a much more powerful information, like your model trains much faster from this. Okay.
Any attempts at trying to take the model, but also add some, say, random ads or random things that do not correspond to any model to kind of learn maybe There's more things, maybe some.
Yeah. I think what Shlomi is talking about is that in recommender systems literature, more generally, it's called explore exploit. That let's say you came to the platform and the first item you listen to is A16Z TikTok algorithm. But that doesn't mean that's all you are. That means I have still not discovered so many things about you. So can I mix it up? Can I show you other things? And TikTok is it's a very good example of something that explores a lot. I mean, you're right. I can only say that by and large, success has come from exploiting so far. Success has come from just repeating what I've seen about you. But, it's changing.
Thank you.
Gaurav, a question from my end. Do you think the model outcomes change based on the law of sort of large or infinite numbers, which is what Google or Facebook might be, versus the law of medium numbers or smaller numbers? Because I'm assuming there's sort of error rates are fairly high, but it obscures when it's large numbers versus smaller numbers.
Yeah. Very good point. I don't have a slide to show that, but certain data sources have less information. And for instance, this click is noisy and you need the decent number of clicks to learn. But certain other data sources are easier to learn. For example, when we started the podcast recommendation model, we had to serve about 700 million users. And we had very little data, about 100,000 data points. And there are 40 million podcasts. So 700 million into 40 million is much more than 100,000. So we have very little data. What we did was we actually forgot about that. We actually used a survey. We sent users a survey of 8 podcasts and asked them to do 1 to 5 rating of it. That data, users' explicit ratings of surveys, was much easier to learn from. So even if you had very little data, literally 7,000 data points, we were able to learn a pretty good model. So my general answer is yes. YouTube with 67 billion hours of videos can use the simplest model and it will be magic. But with less data, you need to think about the data source.
Gaurav, will you talk? Sorry, go ahead, Madhukar.
No, go ahead, Dheeraj.
Will you talk about the engineering challenge of recency and refresh of the recommendation service? Like if I search for flowers, then showing me a flower ad 3 days later might be worthless.
Yeah.
Right, because it could be, Valentine's Day, or it could be a birthday or something,
Yeah.
So how hard is that problem?
Yeah, I won't talk about it in this, as in like, I don't have a slide for it, but typically people solve it by adding a ranking feature. So for instance, okay, I'm jumping the gun, but when I come to 2-stage models, I'll tell you what is ranking, and then I'll explain how to solve. Okay.
So Gaurav, one thing I wanted to ask is, so we're looking to do something on the website too, right? And with the website, we are looking at a tool called Uniform.
Okay.
But the thing that, at least in my mind, I'm struggling with is, unlike an app where the identity is known and you almost have a history, not almost, but you have a history of your behavioral activity, somebody who comes to the website could be, and mostly are, completely anonymous. And sometimes I could, ID them using whatever method, whether it's IP address or whatever, but you clear the cache and now that identity is gone. So how do you create these segments around behavior and personalize for people who are completely anonymous?
I don't have direct experience for it. What I can say is that when we, one thing we did that helped is to make separate models based on the maturity of the customer. Simply speaking, we made a model for users with less than 5 interactions and medium and long. And as opposed to one model for everyone. Technically, that one model for everyone has the features to be able to do everything, but it's just so hard to learn. Making separate models helps. I would just say that you know, an ML answer to your question was put everything in the feature and make, separate models for different user groups.
Another question, kind of somewhat related. How many models do you typically think about making for a given individual, or how do you think about kind of, you know, different kind of like different use cases for the same individual? I guess the thing I'm trying to think through is, like, for instance, in the example of podcasts, maybe like on the weekend, a person really likes to listen to a long podcast.
Yeah.
Go for a long walk, or they go for a long drive or something. Maybe they want a short one, or do a workout.
Yeah, no, very good question. But I think you're saying something very, very important. A lot of people, they look at ML and they feel that where's the role of product here? And, you know, earlier product management was about constructing these user stories and making a solution for them. But now, you know, go to YouTube, there's one model. Where is product here? The product is exactly this way, that you come up with all these user stories and you come up with a solution that delivers it. For instance, I'm not going to take exactly your example. I'm taking some other example that worked for us, is that we showed people recommendations and they said, you're showing me too many politics items. You know, show me something else. So we crystallized that into a need for diversity. And when we implemented something, a very baseline 20-year-old paper, we got 73% improvement in click-through rate. So exactly what he said, like, think about what users want and then craft it into an objective for your ML model. That works a lot. That works well.
One quick question. Actually, in YouTube, I observed, suppose if I'm watching a video, it'll show like maybe top 5, 10 results related to that video, and it'll mix with something else on top of it. Like, you know, that I can see a mixture of like 3, 4 categories. On what basis actually we like can get that kind of combination?
You're showing a video. I didn't get it. You're seeing a video.
I'm watching a video now. I see like recommendations on the right side, maybe 5 or 10 of that related to that video. And I see a mixture of like, you know, some other categories as well. It is not exactly all of them are related to the video I'm watching.
Yeah. Okay. What you're talking about is co-watch. I'll talk about that. And what you're talking about is co-watch and clustering. I'll talk about it. Okay. We talked about this, survey ratings, and this is what I was referring to. We did surveys too because we had very little data. Initially, our more than 50% people marked our recommendations as 1 out of 5 stars. And, later on, the average became 4.1 after personalization. P39 is personalization. All right. Okay. This is kind of the same thing that Matt was saying, is that if you bet on your recommendations, if you change your UX in a way that uses the power recommendations, it's much better. On the left, you see something where just this is the amount of space you give to your recommendations. On the right is an app where you open and all you see is one recommendation. That's how strong a bet this UX is making on that. Okay. Now, just to ground how I've been talking about co-watch. The basic idea is item-item similarity, that show items to you based on that are similar to what you have liked or consumed so far. The way to visualize this is that I've shown it in a graphical form, but you can assume it's a matrix. You can, your visualization is up to you. So let's say these are the items that you can recommend. Now, from your user logs, let's say you observe that after watching video 1, 6 users watch video 3. 20 watch video 2. Like other numbers indicate how many watch those videos. Okay. Now, when you're serving recommendations for a user, let's say the user has watched video 1 and video 3 in the past, probabilistically, you can see, just let's take video 3. And you see the 2 edges out of video 3. This is probability 10 by 13. This is 3 by 13. So this, you sample a path coming out of this node. You sample now the other paths coming out of video 1. In this case, we sample these. And you recommend these videos to the user. You recommend videos to the user who has watched green based on what other videos people have watched after having watched the green ones. Any questions?
This recommendation kind of shows what you've learned from other people and other users. Where's the personalized aspect of, okay, this user cares more about something versus?
Yeah. So let's say I like to watch NBA highlights, and I like to watch Stanford lectures. So let's assume video 1 is NBA highlights and video 3 is Stanford lectures. So so other users, after having watched video 1, would have watched some other highlights, and other users after video 2 would have watched these guys. So what is personal to me is my history. So when I come to the app, YouTube will see, okay, Gaurav has watched this video and this video. I'm going to see what other users have watched after watching these 2. So what is personal is the seed that they're not recommending, I don't know, Peppa Pig to me. Because my daughter uses it, but that's a separate story. They're not recommending Peppa Pig to me because they're not in my history.
The seed is personalized, but after that, it's more recommendations based.
Exactly.
Gaurav, I come back to the recency thing. It's like time elapsed since video 3 was watched versus many days have elapsed since video 1 and video 3 were watched. I mean, the recommendations have to be different, right? Because I mean, Stanford lecture, the top of mind for me when I just watched video 3. Versus, I come back to this system after 10 days of watching video 1 and 3. The recommendations have to be different.
Okay, so you're saying recency in 2 ways: recency from you and recency from the seed. First, you're saying that if I've just watched Stanford videos, then that's top of mind. So you should, right now recognize that. And you're right. So here, what I would do is, let's say I just watched video 3. Then the paths coming out of video 3 have to be given a higher weight. And that's what you do in the ranking stage. You give each seed a different weight. And second thing, what you're saying is that, this is NBA highlights, very nice. But this might be a 2-year-old NBA highlights. For some reason, some people watched it after watching this. How do you take that into account? That is related to retrieval. That's related to the first stage. They might have ideas. I think there are no set ways. What I would do here is I would just periodically keep reducing the weight of an edge. Let's say every 2 days, I'll make it half or something. But you're right. These are the user needs that people anchor on when devising their algorithms, and then they validate it with experiments. Okay. Item recommendation. We just talked about item recommending to the user other items that are similar to what they have watched. Now we'll go into data structures a little bit and data stores. So this is what is needed. We see the history of the user, which is a list of items. Like Dheeraj said, this will not just be a list of items, it'll be some sort of a weight per item, weight per seed item here. But let's presume, that right now the weight is 1. For each item, we are going to get a co-watch, which means a list of other items with scores coming from that item. Okay. At the end, I'm going to ask you, what are the data structures we need for these? Once we have got this, there'll be duplicates. So just merge them. once you have merged them, then you extract features, filter them for offensive or inappropriate content, rank based on your features and your ranking model, get the metadata to show it on a web page, and return the list.
What's the definition of a feature here?
Feature would be something like the date of publish, like video publish date, or age of the video, something like that. It could be also categories or publisher, score, page rank of the website that you found this on, any number of features.
And you said actually you performance issues, you said you'll tell when it comes to this thing.
Yeah. Okay, so this API call for us would take about 2 milliseconds P99. This would, and I'll flip the question to you guys there. Okay, how can we do this? And this API would also, this is also a table lookup. It's of the order of at most 6 milliseconds. This is up to you, how fancy you make it. But usually the full thing, we would not make it, we would not take more than 100 milliseconds P99. You can make it faster, but typically 100 milliseconds for users is okay.
But it's just only fetching part of it. Is it like computing also is just only within 100 milliseconds?
Everything, returning, like this API call should return P99, 100 milliseconds.
What I mean to say is that actually this is already fetched, but it is just only fetching part of it. Is it like, at the time, is there any computation happen?
The computation, right, good point. So computation is happening, a little bit of computation is happening here, merging of IDs, but most of the computation is going to happen in sort of feature extraction and ranking. Okay.
Okay, thank you.
So Gaurav, again, how much would you weigh this versus the recency of the, I just watched something which is not in your data structures in your graph, and I need to use a more a single node based recommendation because it's right there, top of mind for me. The way my chemical enzymes, the dopamine that I need right now versus anything else, the neurotransmitters, everything else is about recency.
Yeah.
And it's not being considered in any of this stuff here.
Right. So I didn't, point them out as features, but you're right. One of the strongest features in ranking is just how new the video is. A lot of video consumption does happen in the first 24 hours, 48 hours. How new the video is. What is the trajectory of use, is the video views growing, this sort of a time series of video views. So all of these are features that you use. And I believe Matt was saying, or I forget who was saying, but if you said this is important to you, but how do I know? The only way to see it is based on user interaction. So what we would do is we'd show a user an old video and a new video and see the user clicked on the new video and then train the model from that. As long as you have the features in there to learn that causality, we can learn it.
Yeah, my point is that the last 2 minutes worth of interactions where a user clicked on something, didn't even watch the whole thing and go back. And then the last 3-4 minutes of their watching history, those things are way more important.
Absolutely.
And those things cannot go through an offline model system and then get fed into an online system through over days or something like that. And that's where a lot of these things fail.
Well, if you look at this, I don't see why they'd have to. I mean, the Git history can be live.
Exactly.
The Git history is live. And that's the only thing that has to be live, and it's easy to make it live.
Well, it all depends on how fast do these things get refreshed and get uploaded, and there's an engineering challenge here, from the browser to the web server to the click stream logs to the backend systems to all that stuff.
Well, worst case, cache it in the session that the user is currently using. And if they go out of that session, it times out, then you have time to backfill.
Yeah. I mean, as long as get history actually is not a siloed team, and instead knows about the sessions and this. I mean, that's where the real engineering challenges lie.
Absolutely. Yeah. I mean, these were sort of my questions: is how do you implement get history to have read soon after write and very low latency access? It will also be needed for your MapReduce jobs, but that has less requirements. So yeah, what sort of a data store? We won't have time now, but what we should talk about is what sort of data store is needed for get history. And Nim, any thoughts on this, on the data stores? I think.
Sorry, you're playing the quiz question on me now?
Yeah, kind of.
Well, how long does the history have to be? 20 entries, in which, if it's just that, put it into an object DB and in one chunk, makes the lookup fast.
Yeah. So what I was a user of this, I was not a builder of this. That's why I don't know. We had a columnar database for each type of item. So for instance, podcast history would be one column with protos of a certain type in that column. And you could query by user. You could also query last X, so most recent X. Typically you would query all of it, but that's the sort of the experience of the data store.
So, I mean, in MZ, we use a Redis cache for doing this, for keeping a history, but we didn't keep a lot of history too. We just kept like a last 10 items that the user looked at it, and Redis has some data structures to give us we had an entry per user ID, just looked it up and updated it and said, okay, here's a recent item they looked at. Sales item, that's different, but yeah.
Okay.
My guess is that there's probably some psychological sort of some psychology here as well, which is long-term history is good for, I don't know, intent versus short-term history for intentless or something. I don't know if there's some such thing to also look at.
Yep. Yeah. These are the terms that we think about in improving recommendations. Cool. Yeah, I'm going to move faster now, start time. But user recommendation is when I recommend you to something, a video to you based on what some other user like you watched. This, why would you need this? We needed this in podcast because we had information of a very small subset of our user set. We did not have item like history for them. So from this very small set, we sort of clustered them. And so let's say I'm not a new user to Google Podcasts. When I log in, based on my search and YouTube history, the podcast app would figure out which cluster I belong to, and hopefully it'll have some users in that cluster who have some, which have some history, and then it will recommend those items to me. Okay. Yeah, item based recommendations, item similarity based recommendations works much better. User based similarity helps you scale to a large user segment. Okay, so this is important. What are our objectives? At a high level, the objectives were, and this sort of trickles down into the metrics, which sort of trickles down to your launch criteria. So this, yeah, we wanted to maximize engagement, satisfaction, and responsibility. Engagement is measured by click-through rate per item, click-through rate at the page level, in podcasts, to average listen time per user per day. So if you're doing A/B testing, then these are the metrics we'd look at. satisfaction, because if you want to sort of not skew towards clickbaity content, then you need, what people do is send a survey and ask, hey, what's your 1 to 5 rating of this podcast? Responsibility is about, inappropriate content. Okay.
Where do you put, Gaurav, where do you put attention span? Like, I am more open for serendipity when if it's a 1 minute video than if it's a 45-minute podcast.
Yeah. Yeah.
So there's a lot more to this than just average time listened per user. We kind of overestimate what people, how intelligent, the masses are. But at the end of the day, they just go to the influencers. Like I shared this thing with you where they're like, look, I just follow people and whatever they do, I basically listen or watch or read. And then the reason why TikTok succeeded was because the content was really, really short.
Yeah.
So there, the value of serendipity is a lot more than if you had content which was 30 minutes of video, which is what YouTube content was or something.
Yeah, yeah. I think these are product questions, and so much so that's why you see a platform skewing towards, like YouTube, for instance. Their core launch criteria is valued watch time. That's why more and more videos are becoming longer on YouTube. That's what the system promotes, and that's what creators also figure out that they need to create for YouTube. And TikTok, like you said, shorter. So these are platform level decisions of what they want their launch criteria to be. Okay. Okay. 2-stage. This is infrastructurally very important. I'm not sure how much it will be important for us, but for big tech companies, you have lots of items to search from. And if you do ranking, if you try to rank among all those items, that takes a lot of CPU. So they have 2 stages. One is this retrieval stage. The names don't matter here, but simply speaking, out of, let's say, YouTube, out of billions of videos, it comes up with about 200 videos in this stage. So you go to the app, you open YouTube app. First, use in about 6 to 7 milliseconds, P99, it would search a vector database and get back items, the video, about 200 items. And then it would do a second level ranking of them, which is much more thorough. Okay. Okay. I'm clearly going fast here. So this is the separation between training and serving. Things you would do in training are, logging in the data, and then log data, you process and transform. You validate that the int is still an int, and that it matches your schema. Train the model. You validate that the model has metrics that are better than the previous model. Then you inject the model, and this is your serving flow.
What is the frequency of training the model, Gaurav? Or is it happening continuously?
Yeah, I think in some cases, like Dheeraj was saying, decency of the item to item graph. Those are the reasons why you would want to do it more frequently. Like in podcasts, we would do it every 3 days. Yeah. So again, not the user history, that is almost real time, but the co-watch, get co-watch, that part is, yeah. Okay. I won't go into this, but there are some model structures like tree-based models, which are faster to learn.
Sorry, sorry to interrupt you, but I have also heard similar things from other companies, like, other music recommendation service, that they take a day or a few days to build this co-watch history. How much do you think is being left on the table by doing that? For newer videos, for example, you don't have any insights, right?
Yeah. So they compensate for it by a certain way. So the model, like for instance, if you see the 2-tower model, one of its features is which is the publisher of the video. So if it's a Lady Gaga song, with the second it was put onto YouTube, I know it's Lady Gaga, so I'm going to have a very high score of it. I don't necessarily, I'm not losing much. It sort of depends on the model architecture. If I'm purely learning that's an important song based on people clicking on it, then yes, I'm going to leave a lot on the table.
Okay. So what is technically different about keeping user movie history versus movie history, or user item history versus item history? How's that technically? One you can do real time, other you can't do real time.
Yeah, so user movie history is the primary source. That's what actually happened in real life. And the item movie causality is a derived source. That's, you would refresh it as fast as you want, freshness and things like that. So there are models which don't explicitly keep that linkage. They just keep a semantic embedding of movies and search it real time.
I'll take it offline.
Yeah. So let's follow up later. Okay. I am going to now, how do I do this? On Slack. Send you a quiz. Sorry?
If you're posting a link, do you want to do it on chat, Gaurav, or?
Yeah, I just don't, since I'm sharing my screen, I don't know how to do that. What? How do I post this link on chat?
Usually on the top, when you share a screen on the top right, you'd have like options where you can open the chat box.
If it's not defined, you can also stop sharing for a second and get there too.
Yeah. It is for people, it is also on, okay, chat, I got it. Okay.
So it's on the general channel, right?
Yeah, it's on general, also on the chat.
So Ansu posted on the chat. Is that the one?
Got it. Yeah.
Perfect. Thank you, everyone. Okay.
So Gaurav, I had to guess on one or two questions. I don't think I got that from the presentation.
You didn't get full marks?
No, I had to guess on one of the questions. That one about.
That's okay. It's only a 10% deduction from your salary.
Yeah, if you have a salary.
Yeah, exactly. Yeah, and if not, it's a 10% deduction of your shares.
Oh no.
We'll give people 1 minute. Oh, yeah, yeah, I'll tell you later when I have one-on-one. Okay. I'm seeing a bunch of results. Okay, I'm gonna share screen. Okay. Okay, 12 responses. Yeah, so which of these, you're right, apart from AlphaFold, all the other ones are examples of recommender systems. This is, the second one is interesting. It's item to item, but with personalization. Yep, user similarity, because the context is the user. Item similarity, would you just listen to? Yep. Podcasts. Okay, from privacy and security perspective, what would you think of a recommender system that while serving Rex to user A accesses the history of user B? We have access to, I guess I can't see it, but user A should not have access to history of user B as long as code is well reviewed. So in Google, we maintain that, yeah, it should not have access to any other user. It was implemented in the data model, but yeah, this is something that we need to figure out and develop. Serving the first browser returning lists. Okay, everybody got this right? Okay, while deciding to launch a new version, which of these criteria should be considered? Average rating, total listen time, click-through rate, page level CTR. Yep, all of them are important. I usually built in 2 stages because it'll be very slow to run a full ranking. Yep. Okay, so this one was for me. I'll go through these later and sort of compile responses. Thank you. That's it.
That was quite engaging, Gaurav, and especially with the quiz also. Everybody was like, I was definitely listening. I just didn't know like what kind of questions they were going to ask later.
Thanks.
Yeah, nicely done, Gaurav. Thanks.
Yeah. Bye.
Thank you.
Very nicely done. Very nicely done.
Thank you.